So are there any questions or concerns where we pick it up, where we left off, right? So we covered page 1, section 3.4 on Wednesday. And then, the notes are correct, we did this example on Friday before a quiz. So let's move to page 3 of your handout. Continue to work these examples. We got 2 more to go. And so I'll probably get the homework released either probably today or tomorrow, but it won't be due until Monday. Okay? There's no rush. All right. So in this example 3A, right, it says factor completely and find all exact zeros of the given polynomial. So part A, we have the polynomial f of x is equal to x to the 4th minus 5x cubed plus 3x squared plus x. Well, right, we got to find all the zeros of this 4th degree polynomial. And you can see immediately that there's no constant term. So we can factor out an x right off the bat. Okay? X is in each of these 4 terms, and the lowest power of x is x to the 1st. So we can factor out an x. So we have x times x cubed minus 5x squared plus 3x plus 1. Now, we have to factor this 3rd degree polynomial inside parentheses. And it's this 3rd degree polynomial that we apply the rational zeros test to. Okay. You can see that the constant term is 1, and the leading coefficient is also 1. So it's that 3rd degree polynomial inside parentheses that we apply the rational zeros test to. Okay. All right. So the integer factors of the constant term 1 is plus or minus 1, right? 1 times 1 is 1, minus 1 times minus 1 is 1. And we get the same integer factors for the leading coefficient, right? Leading coefficient is also 1, and its integer factors again to that are plus or minus 1, right? So this applies both to the constant term and the leading coefficient. Okay. So when you take the integer factors of the constant term divided by the integer factors of the leading coefficient, we just get plus or minus 1 again. Okay. So the possible rational zeros in this problem are minus 1 and plus 1. Okay. So the integer factors of the constant term are plus and minus 1. The integer factors of the leading coefficient are plus and minus 1. Plus and minus 1 divided by plus and minus 1 is plus and minus 1. Okay. So there are only 2 possible rational zeros, okay, for this 3rd degree polynomial. So I put in plus 1 into this 3rd degree polynomial. I have 1 cubed minus 5 times 1 squared plus 3 times 1 plus 1, and that equals 0. So x equals 1 is a 0 of our third degree polynomial. And it's also a 0 of our fourth degree polynomial, right, by default. And x minus 1 is a factor. Okay. So f of x factors into x times x minus 1 times some unknown quadratic q of x. This is a third degree polynomial. X minus 1 is one of its factors. And so x minus 1 times some unknown quadratic, right, equals this third degree polynomial. Okay. All right. So if we divide this third degree polynomial by x minus 1, we can get the unknown quadratic q of x. So q of x is equal to the third degree polynomial divided by the factor x minus 1. Right? X minus 1 times q of x equals this third degree polynomial. So if I divide this third degree polynomial by x minus 1, I get q of x. Okay. Well, x minus 1 is linear, okay? That's x to the first power. So we can use synthetic division, right, to divide this third degree polynomial by x minus 1. So 1 goes in the box, and then the coefficients of our third degree polynomial are 1, minus 5, 3, and 1. And now we perform the synthetic division. Bring down the 1. 1 times 1 is 1. Minus 5 plus 1 is minus 4. Minus 4 times 1 is minus 4. 3 minus 4 is negative 1. 1 times negative 1 is negative 1. And 1 minus 1 is 0. So we have a remainder of 0, which is what we expect. Okay. So these are the coefficients that go with the quotient of this division. Minus 1 goes with 1, minus 4 goes with x, 1 goes with x squared. And so the result of our division is q of x is equal to x squared minus 4x minus 1. All right, you multiply each coefficient by its x term. Okay. So over here, we can now fill in for q of x. Q of x is equal to x squared minus 4x minus 1. So we factor this quadratic. We find the values of x and make that quadratic equal to 0. And we find the last two zeros and the last two factors. Okay. All right. So we set x squared minus 4x minus 1 equal to 0. And then we solve for x. Okay. Well, actually, I'm going to put this up here. So in this example, a is equal to 1, b is equal to minus 4, c is equal to negative 1. So using quadratic formula. X is equal to negative b, which is the negative of negative 4. Then we have plus or minus the square root of b squared, which is minus 4 squared, minus 4 times a, which is 1, times c, which is negative 1, all over 2 times a, which is 2 times 1. And now you got to simplify. Negative 4 is plus 4. Minus 4 squared is 16. And minus 4 times 1 times minus 4 is plus 4. All divided by 2. 16 and 4 is 20. 4 plus or minus the square root of 20 over 2. And square root of 20 reduces to 2 root 5. And again, fraction bars are like division symbols. Division does not undo addition and subtraction. So we have to divide each of those terms in the numerator by 2. And so we have x is equal to 2 plus or minus the square root of 5. So the last two zeros are x equals 2 plus the square root of 5, x equals 2 minus the square root of 5, and then we add them to the first two zeros. Okay, I guess I didn't write it out, but x equals 0 is a 0, right? F of 0 is equal to 0, right? You put in 0 on for x, you have 0 to the 4th minus 5 times 0 cubed plus 3 times 0 squared plus 0, which is 0. Right? That's the result of factoring out the x. Okay. So x equals 0 is the third 0. And we already showed that x equals 1 is a 0. So these are the 4 zeros of our original polynomial. Okay. And now we can factor x squared minus 4x plus 1 because we know what zeros are. Okay. So we have f of x is equal to x times x minus 1 times x minus 2 minus the square root of 5. Okay. Remember, you just subtract, move everything from the right-hand side to the left-hand side to get the factor. Right, the factor theorem says if x equals c is a 0, then x minus c is a factor. And then finally the fourth factor is x minus 2 plus the square root of 5. So that gives us the complete factorization of f of x. So those are the 4 zeros, and this is the complete factorization. Okay. Any questions on that? Okay. So flip over your page, we got one more. And then we'll have this section complete. Now we gotta find the zeros and completely factor f of x equals x cubed plus 2x squared plus 4x plus 8. So again, the leading or the constant term is plus 8, and the leading coefficient is the invisible 1. Okay? So the integer factors of the constant term 8, okay? Well, 1 times 8 is 8, and 2 times 4 is 8, right? So the integer factors of 8 are plus and minus 8, plus and minus 4, plus and minus 2, and plus and minus 1. The integer factors of the leading coefficient are plus and minus 1. So our possible rational zeros list is just going to be the integer factors of 8. Because when we divide the integer factors of 8 by plus and minus 1, we just get the same set of numbers. Okay. So the possible rational zeros are plus and minus 8, plus and minus 4, plus and minus 2, and plus and minus 1. Now, I want you to make an observation here. All the coefficients in f of x are positive. So it's impossible to put a positive number in for x and have f of x equals 0. Because in order for f of x equals 0, when you put a number for x, some of the terms have to be negative and some of the terms have to be positive. So the negatives and the positives cancel each other and you end up with 0. If you put a positive number for x, this is going to be positive, this term is going to be positive, this term is going to be positive. Remember, you're going to have 4 positive terms, and it's impossible to get 0. So x, whatever makes this right-hand side equal to 0, whatever number you put in for x, it has to be negative. So we can immediately eliminate the positive numbers in our possible rational zeros list. Okay. So you got to look at minus 8, minus 4, minus 2, and minus 1. Okay. You don't have to deal with the positive numbers. Well, I tried x equals minus, right, I tried to work with easy numbers first. So I tried minus 1. And when I put in minus 1 in for x on the right-hand side, I got f of minus 1 is equal to 5. So minus 1 is not a 0 on that polynomial function. And then I tried x equals minus 2. Put in minus 2 in for x, so I have minus 2 cubed plus 2 times minus 2 squared plus 4 times minus 2 plus 8. And lo and behold, the value of the function is 0 at x equals minus 2. Okay. So x equals minus 2 is a 0 of this third degree polynomial function, which makes x plus 2 a factor of our third degree polynomial function. Okay. So the right hand side of f of x factors into x plus 2 times some unknown quadratic. We see, you notice you get to a point where you're just doing the same thing over and over and over and over again, right? It's a third degree polynomial. This factor is linear, x to the first, so q of x has to be a polynomial of second degree. Right? It has to be a quadratic. So, to find q of x, our third degree polynomial is equal to x plus 2 times q of x. So to find q of x, we divide the third degree polynomial by x plus 2. So we have x cubed plus 2x squared plus 4x plus 8. We divide that by x plus 2. Well, x plus 2, the divisor is linear, so we can use a synthetic division. What goes in the box? What number goes in the box? Yes, negative 2. Okay. And then you write out the coefficients of our third degree polynomial to the right, which are 1, 2, 4, and 8. And then you perform the synthetic division. Okay. So you bring down the 1. 1 times minus 2 is minus 2. 2 minus 2 is 0. Minus 2 times 0 is 0. 4 plus 0 is 4, and minus 2 times 4 is negative 8. And 8 minus 8 is 0. So q of x, right, this 4 goes with 1, 0 goes with x, and 1 goes with x squared. So q of x is equal to 1 times x squared, which is x squared. 0 times x is 0, and then 4 times 1 is 4. So on the right-hand side, over here we have f of x is equal to x plus 2 times x squared plus 4. Now, since there's no x term, middle term in our quadratic, that makes it easy to solve for x. Right, to get the last two zeros, we set x squared plus 4 equal to 0 and solve for x. And we can use the square root method. Subtract 4 from both sides. We get x squared is equal to minus 4. And then we take the square root of both sides. We have plus or minus the square root of negative 4 on the right-hand side. So we have x is equal to plus or minus the square root of minus 4. You know the square root of 4 is 2. So the square root of minus 4 is 2y. So x equals plus 2y. and x equals minus 2i are the last two zeros, so we're a third-degree polynomial. And the first one we discovered was x equals minus 2. So what's the complete factorization of f of x? If x equals 2i is a 0, then x minus 2i is a factor. If x equals minus 2i is a 0, then x plus 2i is a factor. So this is the complete factorization of f of x. Any questions on that, ladies and gentlemen? So that wraps up 3.4. And like I said, I'll get the homework released either today or tomorrow.